Alright, Bismillahirrahmanirrahim. Okay, so we do the exercise first. Okay, exercise acid base and salt, huh? I think we do this one. This one example, your paper 4. Okay. Mukris. Define the term base.
X is the proton acceptor.
What's that?
X is the proton acceptor.
Okay, yes, proton acceptor. Okay, good job. Okay. Asha, state what is mean by the term alkali?
Oh, we can't write proton acceptor 2, right?
No, sir. Cannot. If a acid, that one we call proton donor.
Yeah.
If a base, that one we call proton acceptor. If alkaline, that one we call soluble base. Soluble base in water. They're soluble in water.
Oh, I thought alkali is like a proton acceptor 2.
No, sir.
Okay.
Base, you have alkaline that way, that one. Okay. This one, I also have in my notes here. This one. This one is a base. Inside the base, you have an alkaline. Yes, the base is a proton receptor. And alkaline also proton receptor. But now they say that what is meant by term alkaline? Why they have a base? Why they have alkaline? Because alkaline we call soluble base. Okay. Is it clear, Asha?
Yeah, it's clear.
Nana, Chacha, is it clear now?
That's clear.
Mukris, is it clear?
This is clear.
Fear, is it clear?
Yeah.
Okay. Nana, what is the color of the thymophthalate for sodium hydroxide?
Colorless?
Mm. Thymophthalate is a CCB, right? Okay. Colorless. Colorless, blue. Acid, neutral, alkali. So sodium hydroxide, Nana, that one is a alkali or acid? Sodium hydroxide. Sodium hydroxide. That one is what, Sayang? Hydro If you see the hydroxide, Nana, that one we call alkaline. So what color for alkaline in the thymophthalate?
Blue?
Yeah, blue. Okay. Okay, so is it clear, Nana?
Yes.
Okay, so another one, Nana. CH3COH, that one we call ethanoic acid. So if ethanoic acid in the thymophthalate, what colors? Nana.
Colorless?
Yeah, colorless. Is it clear, Nana?
Yes.
Okay. So the others, how? Any questions, Sayang, regarding for this one?
No, no questions.
Okay. Fear, free journey. Fear? No.
Yes.
Okay. Pelik panggil Hana Fear. Okay, name the indicator which can be used to identify substance with the highest concentration of hydrogen ion. Name the indicator. So indicator that we learned, remember that I said I have the 4. We have a
what?
Huh? What's it?
The 4?
We have a 4 for indicator. We have a phenolphthalein. We have a thymophthalate. So then we have a universal indicator. And then we have a meter orange. So which one is a more suitable?
I think
You want to define the highest concentration, so it means that one is a strong acid. It's not like acid, alkali, or neutral. Kalau acid, alkali, or neutral, it can be weak, it can be strong. Now, if I mention highest concentration or lowest concentration, so it means that you need to determine the strong or weak by the indicator. Which one can?
I'm building like a tower.
I think methyl orange.
I'm building like this.
Meter orange, how many color? Hannah?
3.
Okay, 3. So if a 3 color, can you determine that one is a strong or weak? So you have a 3 color. What color that one for meter orange? Give me one.
Red, orange, and yellow.
Okay, red, orange, yellow, red, orange. So red for what?
Red, acid.
Acid. Orange for what? Neutral.
Neutral.
Yellow for what?
Alkaline.
Alkaline. So can you determine that one the highest concentration? So it means that the strong acid. Cannot, right?
No.
You just know that one is acid. You don't know that one is a weak or strong. You know it will
is it
change.
universal indicator?
Yes, universal indicator. Because universal indicator, you have a color, that one here. Yeah. Red is a strong alkali, yellow or orange is a weak alkali, neutral is a green, weak alkali, strong acid, sorry. Red is a strong acid, yellow or orange is a weak acid, neutral is a green, weak alkali, that one is blue, strong alkali, that one is purple. So this one universal indicator. Okay, so any questions regarding for this one?
No.
No.
So we do this one until 1 o'clock, all right? So 1 o'clock, your 8 o'clock lah kan? And then the rest, you need to do as your homework. All right? The rest, that one you need to do as your homework. Shall wait. Okay, so. Here, right? Okay, C1. Chacha, what is the mean by the term of acid?
An acid is the proton donor.
Yeah, proton donor. Very good, sir. Mukris.
Yeah.
Mukris, what is the meaning of the weak in the term of weak acid?
Partially dissociate in water to
Yeah,
produce
very,
H plus ion.
yeah, very good, sir. Good job. Partially dissociate in water to produce H plus ion. This one is redox, eh? I will not touch. This one we leave it there. This one under redox. So redox. Redox topic. So this one is a topic. Redox. Alright. E. Okay, so I teach you how. Complete the equation to show the dissociation. Dissociation means that you need to separate. Okay, dissociation means that you need to separate that one. So if you want to separate, it will divide into two. Okay, if you want to separate, it will divide into two. Either that one is strong or weak. Okay, and here, is it clear, sir? Any question?
No.
If a strong and weak, make sure the strong only one arrow. It's not reversible. Weak is a reversible. Here. Okay, Asha, do you still remember what is a strong acid, Asha? They have a three type of strong acid. That one is what?
Is it the Haikasonoti?
Yeah, very good. Sayang Haikasonoti. Haikasonoti. Okay, Asha. Haikasonoti, Haika, that one is what?
HCl?
HCl, hydrochloric acid. So,
HSO?
H2SO4, sulfuric acid.
Oh, yeah.
Noti,
HNO3?
HNO3. So, nitric acid.
Yeah.
Okay. All right. So, Frijani, Nor Frijani.
Yeah.
Okay, Sam. That one is this one is CH3COOH. We call ethanol acid, right?
Yeah.
So that one is strong or weak acid?
Weak acid.
So weak, one arrow or reversible?
Reversible.
Reversible. Okay, right. So if you write reversible, see 3 marks, eh? Okay, if you write the reversible, this one you got 1 marks. Okay, how to separate that one? Remember that CH3COO minus plus with H plus. Okay, please remember, if you want to separate the ethanol acid, all right, CH3COO minus plus H plus. This one we do the latest past paper, the latest past paper, which is May, June 2024. This one have all variant 1, variant 2, variant 3. I think it's a variant only February, March. 42. All right, so any questions now? Before we start to the next.
No.
No.
Okay. Okay, here. Okay, a student prepare magnesium sulfate crystals by adding excess magnesium to dilute sulfuric acid. So write the chemical equation for this reaction. Okay, so I'll teach you how. Chemical equation is how? They said that by adding magnesium. So magnesium, the formula, that one is a Mg. To the dilute sulfuric acid is a H2SO4. Okay, and then what is the product? So remember that Mg2 plus, the charge, sulfuric acid, if you want to separate that one, H plus and SO4, 2 minus. And then you arrow here. So Mg will go to here. Then become this one lah, MgSO4. And then they said, teacher, H2O. I said, no, sayang. Only have a H. If only have a H plus, it will become H2. Plus with a H2. It's not H2O, only H2. Because that one is a metal. If you see the my notes, that one, metal plus acid. Okay, typical of acid, eh? Reactive metal plus acid. And then it will produce salt plus hydrogen gas. Okay, salt plus hydrogen gas. Okay, then you check either balance or not. Okay, please check that one, either balance or not. Chacha, balance or not, Chacha?
Yes, it's balanced.
Very good, Sam. Right, so already balanced. Okay. Describe the two observation which can show the reaction has finished. One. Okay, if you want to describe the two observation. Okay, two observation which show the reaction has finished. Alright. So H2, okay, that one is a bubble gas now. So it will release bubble gas. So when the reaction has finished, stop. Alright. So no bubble gas produced. No more bubble gas produced. So you finish already. So finish means that no magnesium, no sulfuric acid. So no hydrogen. So no more bubble gas produced. Okay, answer that. Is it clear, Nana? Nana, is it clear, Syah?
Yes.
Chacha, is it clear, Syah? Asha?
Were you calling me?
Is it clear, the one?
Oh, yeah. Yeah, it's clear.
Mukri?
Yes, it's clear.
Fear?
Yeah.
Is it clear, the one?
Yeah.
Okay. And then another one, if you want to know the reaction stop finish, the magnesium here, this one, the magnesium here, that one is a solid. Okay, so see, you added the excess magnesium. So when you added the excess magnesium, all right, so sulfuric acid, this one, solid excess. This one is a not in excess. Not in excess, another word we call limiting reactant. Limit that one. So another observation other than bubble gas, you can say about the excess solid magnesium. So no more solid dissolve. No more solid dissolve. Solid you refer for magnesium. It can dissolve. That one solid, it can dissolve. Why? Because no sulfuric acid. Sulfuric acid already finished on. So no reaction for magnesium. That's why I said that no more solid dissolve. So, is it clear, Sam? Any question?
No, no questions.
I have a question.
Okay, sekarang what? Nana, Tasha?
Nana,
Nana, okay. You want to ask what, Sam?
what do you mean by magnesium when the normal solid is dissolved?
Okay. All right. So, you have a conical flask, one. Okay. All right. So, I will put the magnesium. So, magnesium in the solid form. So, magnesium, that one is I put in excess. Excess to means that I added more. I added more. So, so first you have a magnesium plus sulfuric acid. Okay, the first you added magnesium in excess. And then you plus with sulfuric acid. Okay. After complete reaction, No sulfuric acid. No more sulfuric acid. So all the sulfuric acid, complete reaction, all sulfuric acid completely react. Okay, until that, is it clear, Nana?
Yes.
Okay, then you left magnesium. So magnesium is in solid. Then you stir, it will not dissolve. You stir again and again, no more solid will be dissolved. Still have a solid. Why? Because no sulfuric acid in the beaker, in the conical flask. Is it clear, Nana?
Yes.
And then the student said, teacher, still have a solution. Yes, that one still have a solution. But this one is a magnesium sulfate. Magnesium sulfate. The solution of the magnesium sulfate. Magnesium sulfate is a soluble salt. So that one in the solution form. Okay, is it clear? Nana?
Yes.
Okay. Alright, so any questions before we proceed to the next?
No question.
No.
I think I will send this exercise in the group. Okay, that one I write down that one, the answers. Okay, let's see. State the general name given to the solid separated from the solution by filtration. Solid separated from the solution. Before I explain that one. Fear. What is the general name for given to the solid separated from the solution by filtration? Fear.
Huh?
This one, Fossey. What is the general name given to the solid separated from the solution by filtration? You understand or not, Sam? Sorry. Do you know the process of filtration? Do you know filtration?
Yeah.
Okay, filtration you need to have what? When you do the filtration, you have what? What apparatus that one? What, Sam?
Filter paper.
Filter paper, okay. Filter paper. So, filter paper inside
A funnel.
filter funnel. And then after that,
Mm,
you have this one we call
beaker.
beaker. Conical flask. Filter funnel. And then you have a conical flask. This one under filtration. Okay, so then they state the general name given to the solid here. This one. This solid here. Separated from the solution by filtration. Okay. In the conical flask, we call filtrate. This one you need to remember. The term you need to remember because always use in your paper 4. In the conical flask, we call filtrate. In the filter funnel, this one we call residue. Okay. So, is it clear now?
Yeah.
So, any question?
No.
No. Okay. Hmm. Sekejap, wait. Okay. This one. F and G. Before that, any questions for the residue and filtrate? Any question for residue and filtrate? For the filtration?
No.
No, Everything okay, Okay, now. The last question, F and G. Name the substance other than copper oxide, okay, other than copper oxide that can be added to dilute sulfuric acid to produce copper 2 sulfate in step 1. Other than copper oxide that can be added to dilute sulfuric acid to produce copper 2 sulfate. Who want to try this one? So this one first, metal oxide. So plus with acid. So then you got the salts plus water. So other than copper oxide, which one? What? Nana? You know not Nana? The one?
Can you do with metal carbonate?
Yeah, can. Metal carbonate, that one is what? What the name?
What do you mean by that?
If a metal oxide, this question we use the copper 2 oxide, is metal carbonate.
Oh, salt plus. Do you mean by that or
Okay, so salt plus
CO2?
CO2 plus
H2?
okay, H2O, water.
Uh,
Okay. So name the other substance, right? Okay. Other than copper 2 oxide. This one metal oxide is a copper 2 oxide. It's a metal carbonate.
CuCO2?
CuCO3.
Oh, okay.
But they said that name. If you answer the CuCO3, it will be wrong. So what is the name for the CuCO3?
Copper carbonate?
Copper?
Carbonate?
Copper carbonate. Okay. So if you forgot here, you see that one there's 2 So if a 2,
Oh,
you need to write 2.
uh-huh.
Okay. Any questions? No.
No.
So the others how? It actually can be copper 2 carbonate, can be copper 2 hydroxide. And then teacher, can be copper? No. Copper no, because that one is less reactive. Copper, silver, and aurum cannot react with acid. Right. That's why we call reactive metal. Not all metal can react with acid. Not all. So copper, silver, and aurum cannot. Okay. Any questions?
No.
Everything okay? All of you okay?
Yes.
Right. So the last, name the process used to separate excess copper 2 oxide from aqueous copper 2 sulfate solution in step 2. You want to separate that one. Mukris. So what process Mukris that one?
Nutrition.
Hmm?
Is it nutrition?
Filtration. Filtration kan? You said filtration kan, please.
Yes.
Filtration. Yes, name the process. If you want to separate copper to oxide from copper to sulfate, please use the filtration. Teacher, why? Because copper to oxide is in solid. Copper to sulfate is in solution. So then you can separate by the filtration. Okay. So any questions now? Before we take break, and then before we go to the new chapter. Any question? No.
No.
Okay.
No.
So we take break only 5 minutes, huh? Now is 1:07. So 1:12, 8:12 lah. So we start back on. So 5-minute break. Okay, sayang, we continue. Okay. This exercise for acid, base, and salts. Okay. All right. So we continue this one next week. So next week, I will teach you the rest question because the rest question is so hard actually. Like, for example, wait, which one? This one. I need to teach you how to do the practical detail. This one is not paper 6, It's not the under paper 6, still under paper 4. Right? Because this one they have a practical detail. You need to that one I teach you to Hazim always fast raya di rumah. No. Tariq help all friend rule drift. Okay, and then you need to do the chemical equation. So next week I will continue to teach you this one. I will guide you for to do the exercise. Because this one also saturated and unsaturated. Limiting reactant. So next week we continue for the exercise, okay? All right, so we continue for chapter 10. Any questions regarding for this exercise? Before I proceed to chapter 10. Nana, Chacha, any question for exercise acid base?
No.
No. Asha?
No.
Mukris?
No question.
Phil? Any question, Phil?
No.
No. Okay. So next week continue for exercise acid base. Okay. We done chapter 1 until chapter 8. Okay, story of fraction. Alright, so we left the chapter 9 and 10. We done chapter 11 and 12. Alright, so today I will continue chapter 10. Okay, come. Okay, chapter 10. Chapter 10 is about redox. Okay, chapter 10 is about redox. Okay, what is meant by the redox? Redox is oxidation and reduction that occurs simultaneously, which is at the same time. Alright, oxidation and reduction that occurs simultaneously or at the same time. So means that oxidation and reduction must be together. If you have a chemical equation, you need to have oxidation and reduction. That one we call redox. If only have oxidation, no reduction, that one is not redox. Okay, redox, you need to have oxidation and reduction. Okay, and for oxidation and reduction, alright, redox, you will learn 3 terms. Okay, how to remember for the 3 terms? Okay, you remember the gills. You know the fish punya gills? Alright? So, golo, iodo, lega, LHGH. But I cancel LHGH because this one only have in the SPM. It's not in IGCSE. Alright? If you take the SPM for chemistry, and then you need to know LHGH. If IGCSE, only these 3. Okay, what is meant by these 3? This one, the way, the acronym that you need to remember. Alright? So go low, gain oxygen for oxidation. If I lose oxygen, that one is reduction. Increase oxidation state or increase oxidation numbers, that one is under oxidation. Decrease oxidation number or oxidation state, that one is under reduction. Lose electron, that one under oxidation. Gain electron, that one under reduction. L for lose, G for gain. I for increase, D for decrease. G for gain, L for lose. Right. So remember that one. Gills, go low, iodo, lega. Okay, so I teach you one by one. How to use golo, how to use iodo, how to use a lega. Come here. So this one is your chemical equation. Okay, this chemical equation is your redox. Why redox? Okay, this one is a reactant, this one is a product. After arrow is product, before arrow is a reactant. Then you see the Mg and MgO. Oh, teacher, I go to Mg and CuO. No. It must from reactant, it will go to the product. It's not reactant and reactant. It's not together. No. Okay. Reactant and product. Mg and Mg. Cu and Cu. If you see here, Mg to MgO. Oh, teacher, Mg to MgO. That one is a gain oxygen. Yes, gain oxygen. So gain oxygen under oxidation. So Mg, it will change to MgO. Alright. So under oxidation process. And then CuO to Cu. Okay, CuO to Cu. The lose oxygen. Lose oxygen. If I lose oxygen, they're under reduction. See? You have oxidation, you have reduction. So that one we call redox. Because redox, oxidation and reduction occur simultaneously or at the same time. At the same time. Okay, before teacher proceed. Is it clear, Nana?
Yes.
Chacha, is it clear?
Yes.
Asha,
Yeah, it's clear.
Mukris,
Yeah. Okay.
Fion?
Yeah.
Okay. All right. So, magnesium, this one, undergo the oxidation process. Yes, magnesium undergo the oxidation process. Why? Because magnesium, it will gain oxygen. And then magnesium is oxidized to form magnesium oxide. Why we call oxidized? Because magnesium undergo oxidation. So that's how we use the word oxidized. Teacher, can I write the magnesium undergo oxidation to form magnesium oxide? Okay, magnesium undergo oxidation to form magnesium oxide. I said wrong. The term for oxidation for process, magnesium undergo oxidation process. And then magnesium oxidize to form the magnesium oxide. If you want to say about the copper, copper to oxide undergo reduction process. And then copper to oxide is reduced to form copper. Reduction, reduce. Oxidation, oxidize. So, and then after that, if a magnesium, that one is undergo oxidation, magnesium is a reducing agent. You opposite kan dia, opposite that one. Oxidation, reducing agent. Reduction, oxidizing agent. So copper to oxide here, alright, copper to oxide is undergo reduction. So it means that copper to oxide, that one is a oxidizing agent. You opposite in that one. You can recognize oxidation and reduction. After that, you opposite. Oxidation, reducing agent. Reduction, oxidizing agent. So this one always at the right turn. It's not product, right turn. So before teacher proceed, any questions?
No.
No, no questions.
Yes. Okay, if you want to know why magnesium called reducing agent, okay, I will explain now. Magnesium undergo the oxidation process. Magnesium need oxidizing agent. Who can be the oxidizing agent? Copper to oxide. Why copper to oxide is oxidizing agent? Because it will give oxygen to the magnesium. That's why copper to oxide is an oxidizing agent. So, copper to oxide. Copper to oxide, they need to undergo the reduction, which is a lose oxygen. So, and then copper to oxide need to lose oxygen at where? At the magnesium. It need to give the magnesium. They need to give the oxygen to magnesium. So when they give the oxygen to magnesium, automatically magnesium has a reducing agent. Okay. Is it clear? Sam? Any question?
No, no questions.
No question.
Nana, Chacha? Fear?
No, no questions.
Okay. Number 1. Who want to try?
I think it's A.
We say A, eh? Nana, Chacha?
Chacha.
Chacha. Okay, Chacha say A. Anyone want to try? Before I explain that one?
So I think it's C.
Muki said B.
C.
What's that?
C.
C.
Yes.
Yeah,
that-
I think it's C too.
Huh? Asha said what?
C.
C. Fear, you want to try? Nana, you want to try? Okay, teacher explain one. Okay. If you get the question for the redox, you see the word oxidize, you see the word reduce, automatically you write my acronym. Or teacher, I write the guilds. Okay. And then say golo, iodo, lega, LHH. And then you cancel the LHH. The left side is oxidation, the right side is reduction. Yeah. Itu the first type the first type one. Okay. So then after that, you determine that one. Which one oxidation, which one reduction. Iron trioxide to iron. Now, iron trioxide to iron lose oxygen or gain oxygen?
Lose?
Okay, lose oxygen. So when you lose oxygen, that one is oxidation or reduction?
Reduction?
So reduction. So when the reduction, iron trioxide, oxidizing agent or reducing agent?
Oxidizing?
Oxidizing agent. Okay. Aluminium to aluminium oxide. Okay. That one is gain oxygen or lose oxygen?
Gain oxygen.
Gain.
So gain oxygen, that one is a reduction or oxidation? Oxidation, right? Because go oxidation. So aluminium is a reducing agent or oxidizing agent? What's that?
Reducing?
Okay, reducing agent. So before teacher proceed, any questions regarding for this one?
No.
No. Okay, now we check one by one. A, B, C, D. Aluminium is oxidized. Yes, because aluminium undergo oxidation. So A is correct, that one. Aluminium oxide is reduced. Cannot, sayang. I mean that cannot because aluminium oxide is a product. If you want to use the term oxidize and reduce, always at the rectan. Rectan before arrow, Okay, ni rectan. This one is a product. Before arrow, you use the word oxidize and reduce. Aluminium oxide is a product, so cannot, wrong. Totally wrong. Okay, for the B. Then iron trioxide reduction. So reduction, supposedly that one is a reduce. Is it clear? Mukris, Asha.
Yeah, it's clear.
Nana, Chacha, Fir, is it clear?
Yes, it's clear.
Iron is oxidized, automatic again product. So no. Okay, so the answer is a A. Okay, good job, Chacha. So any questions before we proceed to the next last question?
No.
Okay. No, Okay, number 2. Who can answer, you can leave it the class.
I think B.
What's that? Nana Chacha.
Chacha.
Chacha said B Chacha.
Yeah.
Okay, Chacha said B. Anyone else want to try? Anyone else want to try?
I think it's B as well.
Yeah, me too.
Chacha said B. Nana said what?
B.
Nana said. Please, Phil, you want to try? No.
Okay.
Hmm?
B.
Okay, said B. Phil? It's okay, the line okay? Phil? That was okay. Maybe a line. Yeah. Alright. So all of you got correct that one B. Because Fe, this one they lose oxygen. Lose oxygen, golo reduction. Zinc oxide, zinc. Lose oxygen, still golo. Lose oxygen reduction. NO. O oxygen one. Lose oxygen, still golo reduction. So oxidize only for carbon. Gain oxygen. Done. Any questions before we continue? We finish the class.
No.
Question.
Okay, so next week we continue again. Before the start class, we have a quiz. And then after quiz, we have a revision for paper 4. Okay, and then the half an hour we do the chapter 10. Inshallah next week we finish chapter 10. Okay, because only they have another 2, which is a term for I need to explain oxidation number and also the loose electron. Then we finish already chapter 10. Okay, so we finish here. Okay, bye. See you next week. Assalamualaikum.
Terima kasih. Assalamualaikum.
Assalamualaikum.
Bye.
Bye sayang. Good night.
Good night.
Good night.
Good night.
Hmm.
I'm gonna